I am John Paul Raj and I'm on a mission to make the learning of math fun. So if you're new to this channel, please do consider subscribing. This is part 2 of continuous functions. So if you've missed the first part, I will link that video in the description box below. Please go ahead and take a look at it. Let's dive in. When we talk about continuity over an interval, we need to discuss what is continuity over an open interval and what is continuity over a closed interval separately. So what does that mean? Okay, for an open interval, we know that the endpoints of the interval are not included. Okay, that's how we represent an open interval, which means the endpoints are not included. And if the endpoints are not included in the domain, the values, their corresponding values, FA, FB, will not belong to the range. Right? Because if there's no input, there's no output. So what does it look like? Well, if I just draw a quick representation of that, and if this is the function, okay, let's just, the endpoints that are holes, all right? So if this is my B, and if this corresponds to my A, as you can see, this will correspond to FB, and this will correspond to F of A, okay? All right, so as you can see, the endpoints are not included because it's an open interval, and therefore the values FA and FB also do not belong to the range. Okay, so every value in between FA and FB are part of the range except for those end values. Okay, now if you look at the graph of the function, it is continuous at every point in between. Any point in between you take. Okay, let's take a point here. Let's call it C. At that point, C, the function is continuous. You pick another point here. Let's call that C1. Maybe this is C2. And at that point, the function is continuous. So continuity over an open interval means that for any point, any C in that interval, for each point in the interval, the function is going to be continuous. Forget about the endpoints, but at any point in between A and B, the function is going to be continuous. But what does it mean that the function is continuous at any point? Well, we already saw that in an earlier video, that for any C in between A and B, FC must exist. The value of the function must exist. That means the function must be defined at that point. The limit of the function as x approaches C must exist. And the value of the limit as x approaches C must be equal to the value of the function. So for every point in between A and B, the function must be continuous. Then we say that the function is continuous over an open interval. Now, how is continuity over a closed interval defined? Well, first of all, let's look at what the graph of a continuous function over a closed interval, what it looks like. As you can see, that both A and B are part of the domain. We write the closed interval like this with a rectangular bracket to indicate that both A and B are part of the domain. And if there is an input, there's got to be an output, which means that the corresponding y values, if this is FA and if that's FB, they both are part of the range, which means the function is taking every value between FA and FB. So the definition for the continuity of a function over a closed interval, remember we're talking about closed interval here, okay, is that the function, first of all, must be continuous over the open interval. Open interval AB means that for any point in between A and B, any point seen between A and B, just as we saw for continuity over an open interval, the function must be continuous. Those 3 points must be valid for any point in between A and B. But there is an additional point to be noted about these endpoints A and B. You see, in the domain, we don't have any values of x to the left-hand side of A, and we don't have any values of x to the right-hand side of B, which means that at A, which is the left end point of the interval, we only have a right-hand limit. And at B, which is the right end point of the interval, we only have a left-hand limit. And that is why, how do we define continuity over a closed interval AB? Well, first of all, the function must be continuous over the open interval AB. That means for any value seen between A and B, the function must satisfy those 3 conditions for continuity. If C must exist, limit as x approaches C must exist, and the value of the limit must be equal to the value of the function at that point C. And secondly, at the left end point of the interval, the right-hand limit must exist, and it should be equal to the value of the function at that point. And at the right end point of the interval, the left-hand limit must exist, and it should be equal to the value of the function at that point. I hope this helped you understand the difference between continuity over an open interval and continuity over a closed interval. I'm going to see you all in the next video.